Alright, Shaima, Newton's first law, you say, okay, first just copy it down. Okay. Now, see, in the last class, let me just quickly revise it what we've started with. So basically in kinematics, when we were studying, we were just seeing that a vehicle was moving, right? So what was the velocity? What was the displacement? What was the acceleration? All these things we were discussing. Now, in laws of motion, we discussed the cause. Why was the vehicle moving? These kinds of questions we didn't answer when we were studying motion in a straight line on projectile motion. Fine. So why does a vehicle move? Why an object moves? That is due to the force. So basically, this chapter is all about forces. So this was the introduction which we had discussed. Then I told you we started with the Newton's first law, which you've already done in your lower classes as well. That is the Newton's first law of motion is based on law of inertia. This is also called law of inertia. So what is this law of inertia? Basically, it says that inertia is a tendency of the body to remain in that state. Means if I am sitting, I'll continue to sit till an external force is occurring, right? If I am moving, my body will tend to move until an external force is stopping me. Fine. If I'm moving in a straight line, that is a direction. So I'll continue to move in a straight direction. All right. So this is what is meant by inertia. So inertia of rest, inertia of motion, inertia of direction. So I hope this is revised till here, although we have missed also the last segment of inertia, because inertia is the basic quantity which we have already studied. And first, it's not a quantity. This is not a physical quantity which is present. It's just a name given to a property. There are so many properties present. So it's just a name that is given to one of the properties. That this is inertia, this tendency of the objects to remain in this state, this is called as inertia. Fine. Now, see, there's a concept of momentum which I have to discuss with you. What is this concept of momentum? See, momentum means how much amount of motion is left in the body. If a vehicle is moving, suppose the vehicle is moving with, or let's leave the vehicle. Vehicles have engine. Let me give you an example of human body. If a cricketer is moving very fast, all right, if a cricketer is moving very, very fast, and suppose the cricketer catches the ball, now he has to stop, but he is unable to stop. So what's the reason behind this? The reason behind this is that basically there is so much momentum in the cricketer. That is, there is so much amount of motion in the body that the person is unable to stop quickly. Just a second, let's just discuss. So see, yes, class, sorry. So I was saying, so momentum is the amount of motion that is left within a body. Suppose there's a cricketer who has to catch a ball because he was running very fast. So there is a lot of momentum. There is a lot of motion present inside the body. Now, when the cricketer catches the ball and he just wants to stop, he has caught the ball. He just wants to stop now, but he is unable to stop. So the reason is that there's a lot of momentum present inside his body. Means there is some amount of motion still left within the body. That's why the cricketer has a tendency to. Or one more example you can see. If I have a box placed, suppose I have kept a box over here, and I am throwing this here to it. So it should, at such a speed, if I throw, that it just stops here and it will stick to this, whatever object is this. Now, if I have thrown it with a lot of velocity, what will happen? At the end, some amount of momentum will still be left in it. So which has to be stuck over here, now will drift it apart. Why? Because there is some motion now left in this object, which I was throwing it with certain velocity. So once this is thrown, this also slides. So basically, momentum is the amount of motion which is present inside the body. Rest of you class, is the instruction only for Jyobita? Every time I have to remind you about the cameras? And Sabiha, not once you have obeyed this. Straight away a message will be sent to your parents. Every time I have seen, Jyobita is only following the instructions. This is not how the class will go on. Yes, so this is the definition of momentum. Now, how to represent it? We have the symbol P. P represents momentum. All right. Now, class, sometimes you will be confused with the symbol L also. So keep this in your mind that this L symbol, this is for angular momentum. We'll be studying about this in rotational dynamics you have. So there are certain symbols like force will become torque, and there are things we study in that rotation. So if you see L, written in terms of momentum something. So immediately just write it in the corner of your notebook somewhere so that you remember it, that L is for angular momentum. Angular momentum means in terms of rotational dynamics. Rotation, that momentum, that amount of motion left in the body, that is angular momentum. All right. For linear momentum, we only use P. Now, momentum is the product of mass, it's a scalar quantity, and velocity, which is a vector. So what are these? P is momentum, M is the mass. Now, mass of the object. Mass of the object means which is moving, which is in motion. Because if velocity is zero, momentum is zero, there is no momentum, right? So you have only concept of momentum when there is a motion. And V is the velocity of the object. Velocity of the object. So P is equal to M into V is the formula, right? P is equal to M into B. This is the formula. Now, momentum, it's a vector quantity. It's a vector quantity means that this has a magnitude as well as direction. So if two objects are present with certain angle between them, or even if without the angle, you have to be aware of the angle which is present in between them. Understand? You have to be aware about the angle which is present in between them, because you cannot just straight away add them or subtract them. You have to use proper vector laws. Parallelogram law we have already studied. If anyone wants to revise it, you can always do it. Fine. Just write down this page, then I'll discuss some more things. And yes, just wait. Let me discuss this also. Just wait, class. Direction is same as that of velocity. If the body's velocity is acting towards the right, momentum will also be towards the right. It's like sort of, you can understand this in a manner that it is like kinetic energy. But kinetic energy is completely scalar quantity. That's a different thing, and it's energy. But somewhat you can relate it with kinetic energy. All right, those who know the concept. Otherwise, we'll be studying about kinetic energy also. So direction is same as that of velocity. Now mass SI unit is kg, velocity is meter per second. So the complete SI unit will become kg meter per second. Write it down, then we'll see questions based on this. 50. Yes, 50. Mass is 10 kg. Velocity is 5 meter per second. So, of course, the answer is 50. So, momentum, this is equal to 10 into 5, which is equal to 50 kg meter per second. Now, whatever is the direction of velocity here, it's not mentioned. So, we will also not mention it. Whatever is the direction of velocity, that you will have to mention if it's mentioned. Fine. Now, you can write down this. Just wait, class. See, inertia, when the momentum changes, inertia also changes. Why? Because if the momentum is about the motion, amount of motion a body is holding, right? If the body is holding a certain amount of motion in itself, if that motion increases, right, that distance increases, that velocity increases. So it can happen that if the body was at rest, it will be in motion, right? So this is a way where momentum can change the inertia also. So external force will not be zero in such cases. All right, because inertia will keep on changing. Write it, then we'll discuss the Newton's second law, which is also very important. Yes, NFC, momentum changing part in this manner. Suppose momentum has increased. So it means, suppose I am moving and the momentum which is present inside me has increased. So where I was about to be in the state of rest because of extra momentum which is present, now I'll be moving. So inertia of rest changed to inertia of motion. So inertia is changing in such case, right? So this is what is meant by that when the momentum is changing, it can change the inertia also. Fine. So whenever momentum is changing, inertia is also changing. This is it. Write it, text me done, then I'll. Runner, which example, Shaima, just elaborate it. Just write it, just elaborate it. Which part exactly? Anything, not even just why just a runner, anything, any even non-living object also, just an object which is present. If it is moving, it will be having momentum. Runners definitely have momentum. You see, when there's a finishing line in a marathon, when the sports people they are running, exactly at the finishing line, they are not able to stop. Why? Because they have momentum in them, which let them remain in the state of motion. Let them remain in the state of inertia, of motion. That's why runners are also very good example of momentum. They have so much momentum inside them that they are able to They're unable to stop even after they have crossed the finishing line. You have seen not a single runner is just exactly able to stop exactly at that finishing point, right? Even if we also move, we'll also move a little more. So that is a right example, Shaima. Now, uh, when we were studying about inertia, what did we study? That the body force is applied, right? Now, this is what the first law deals with, which this external force is occurring. What is the story behind this external force? So here we'll be studying about the external force. So basically, whatever is the rate of change of momentum. Rate of change of momentum means with time, how much momentum is changing, whether increasing or decreasing, both are valid. But how much momentum is changing? Fine. So in that case, how much momentum is changing? So, so see, when we are calculating this external force, the change in momentum divided by the change in time, this gives us the average external force when we are calculating. So this gives us average external force. So how can you calculate it? P final minus P initial divided by final time minus initial time. So this will give us the average force. If we are calculating the instantaneous force, then we'll differentiate it dP over dt. Simply we will differentiate it. Now, when we are talking about the instantaneous force, there are two forces, average and instantaneous. So this is not about the instantaneous force, it is actually about the forces. Instantaneous force is a part of force. So when we are talking about a force, forces are average, which is for a particular duration, instant for a particular time instant. Write it down first. So what is the Newton's second law exactly? Newton's second law is exactly that it tells us the relation to measure force. How can we calculate this force? Which part, Zainab? Can you repeat the second law of
No.
motion? Okay, voice was lagging. I'll repeat it, class. Second law of motion basically talks about, see, first law of motion was about how the momentum is present, right? First part was all about that if a body is in a particular state, suppose I'm in a state of motion, I'm in a state of rest. So I'll continue to remain in that state. First law was all about that. Second law is about that if the state is existing, if an external force can only change the inertia, whether it's inertia of rest, inertia of motion, or anything. So, what is this external force? So, it deals with the external force. Second law. First law dealt with inertia. Second law deals with how to change inertia. That is the external force. Now, external force is basically rate of change of momentum. Rate means something which is changing with respect to time. So, how your momentum is changing with respect to time, this is given by the average, this is given by the force. All right. Okay. So, yes, so how much the force is changing. So, rate of change of momentum gives us the external force. This is a way how to calculate the external force, right? So, when you take delta P minus delta T, that is final momentum minus initial momentum divided by final time minus initial time, that gives us the average momentum. And instantaneous is when dP over dt means you simply differentiate. That's what I have discussed. Write it down. External force is only the acting force, Zainab. Both are the same. That is just a name given. External, why? I'll tell you this concept. I'll tell you this. There's this concept of system and surrounding. So basically, system means whatever we are taking under consideration. So anything apart from that becomes external. External force, external anything, whatever physical quantity is present. So yes, external force is actually the actual force acting.
Ma'am, can you scroll down?
Tabiha, are you present in the class? There's no response from you. Write in the chat column or unmute yourself right now.
Can you scroll?
F means instantaneous force. Okay, class. So see, if we are talking about this equation, F is equal to dp over dt. Now we have studied that momentum is equal to mass into velocity, right? So here also momentum will be equal to mass into velocity. P is equal to m into v. So F is equal to d m into v over dt, right? Now see, mass is constant. We'll not take a quantity whose mass is changing. This is actually more like a condition. Now see, m constant, we are left with dv over dt. What is dv over dt, class? What is dv over dt? Anyone who knows this? dv over dt is velocity. Wow. Velocity divide rate of change of velocity is velocity. Very good, class. Speed and velocity are the answers you people giving me. What is dv over dt, class? Jesslyn, what's your answer? Just text. Acceleration, obviously. How come are we studying the fourth chapter? I was thinking that we are going very slow because we should have at least completed work, energy, and power. First of all, you people are very uninteractive. Only few students have the habit of responding. It's always Shaima and Zainab who are very active, and Jobita also answers. Jesslyn also Sabiha has just turned off her mic and camera. She has not responded. This is not the way you attend a class. See, class, rate of change of velocity. If you people will forget rate of change of velocity, how will you be able to manage the other portions? Acceleration, obviously it's acceleration, right? Rate of change of velocity is acceleration. Please, class, keep on revising, and if you need any help, let me know. Because without this class, you all will be in trouble. Acceleration, velocity, displacement, these are the quantities that will be throughout, not just in class 11th, in class 12th also. Acceleration. So this is acceleration. So final formula is F is equal to ma, which you have already studied in your lower classes as well. F is equal to ma, Newton's second law. So it's a vector quantity force. SI unit is Newton, like 7 Newton, 5 Newton, 6 micronewton, 3 Newton, like this you will hear. CGS unit is dyne, and in dimensional analysis we have done this question also, how to convert 1 Newton into how much time, right? Copy it down. Anything you want to ask, please ask. See, I never just stop at the point where you have not understood. I ask you. So even if you have not understood, just let me know. But keep on revising the previous portions also. Fine, write it down, write it from here. Okay, Sabi, I have received your message. Okay, she has left. Okay, she's having internet issues. Okay. Zainab has answered. Other students answer. Yes, correct. Answer, Shaima, your answer is right. See, here the body starts at rest and attains a velocity of 10 meter per second in 5 seconds. And the mass of the body is 5 kg. We have to calculate. Yes, and now your answer is right. And we have to calculate the force. So see, V is 10 meter per second and time this is 5 seconds. So V is equal to U plus AT, right? Because we do not have acceleration, we only have the mass, and for force we require acceleration. See, initial velocity is 0, so 10 final velocity will be equal to 5a. So from here we have acceleration equal to 2 meter per second square. Mass is 5 kg. Force will directly be m into a.
Ma'am,
Yeah,
ma'am, I was not able to send the answer.
acceleration. So you
Yes,
are
ma'am.
using your formally accelerated equation, so it will be
Yes,
calculated.
ma'am.
10 into.
I was not able to send the answer in the chat box. I got
Yes,
the same.
Jobita?
I got the same answer, but I was not able to send it in the chat box.
Why? You were not, are you not able to write anything? Just check because
Ma'am,
Zainab and
when I'm
now
sending it, is Amna ma'am
first
is not there.
any text.
Ma'am, it's saying Amna ma'am is not in this meeting.
What exactly it's showing, Jobita?
Ma'am, I will send a screenshot to Learnivio.
Okay.
I'm not able to send anything from chat box.
Yes, you can use here, Shaima, the formula acceleration, because ultimately it's a velocity by time only. Here the velocities hasn't changed, that's why we can use, but since initial velocity is not mentioned, that's why we are able to get velocity by time. Otherwise, it's not necessary that we'll get this. Jobita, Zainab is suggesting to reselect the name. Okay, have you not clicked my name in the direct message?
Yes, ma'am, I have clicked it.
Just click again.
Yes, ma'am, now I send it. Ma'am, you got the answer?
It's coming. I'm not in the meeting. I think there's a glitch in the Zoom only because you're able to hear me and everything.
Yes, ma'am. Now I send the answer.
Now check again. Yes, now you're able to send, no? Okay.
Yes, ma'am.
Jesslyn, magnitude is correct. See, a scooterist moving with a speed of 36 km per hour sees a child standing in the middle of road. He applies the brakes and brings the scooter to rest in 5 seconds, just in time to save the child. Calculate average retarding force. Jesslyn, from here only you should have figured out about the signs. Somebody send the answer. Somebody has just unsend it. Okay, we have to calculate the average retarding force. If the mass of the vehicle plus the driver is given to us as 300 kgs. Okay. Shaima's answer is absolutely correct. Out of all the answers from Jesleen, Shaima, and Jyota, I'll tell you how. Firstly, we have the velocity as initial velocity as 36 kilometer per hour. So our first step is that we have to convert it into meter per second. So we'll multiply it by 5 by 18. So this is 2. 2 into 5, 10 meter per second. Then V is equal to U plus 80. So see, final velocity is 0. Why? Brings it to rest. And time is 5 seconds. This is 10 meter per second. This we have to calculate. And this is 5 seconds. No, only Shaima's answer is right. So acceleration will be C. The equation will be 0 is equal to 10 plus 5t. So, not 5t, 5a. So, here 5a will be equal to minus 10. So, you have the acceleration as minus 10 by 5, which is equal to minus 2 meter per second square. What is the mass? 300. So force is equal to ma, which is equal to 300 multiplied to minus 2. So how come is it 600 class? It is minus 600. It's a vector quantity. You can use negative sign. So magnitude was correct. Zainab also, Jobita also, Jesleen also. But Shaima's answer was complete. Write it quickly, then we'll see the third law. Class, let us discuss now the third law of motion as well. Last third law of motion. See, Newton's third law of, see, this chapter is not a very huge chapter. Basically, this part was very important, which we have discussed till today's class. All right. Inertia and Newton's laws, this part. Then pulley mass system is very easy. Frictional force, then from there again, wherever the force is there, no, that portion is important. And see, class, circular motion is not actually a part of this chapter. It's a part of work, energy, and power, but I'll be completing it here because all the concepts are related with this chapter. And by the time we'll be moving there, then you'll be forgetting this. So we'll be completing it here. So pulley mass system will be completed with friction. It's a very short topic. Free body diagram, how to draw it. We'll be doing this. Then till circular motion. I wanted some extra classes if we can have. Are you all people having the vacations right now?
Yes, ma'am.
Yes, ma'am.
All of you? Shaima has answered, means Zainab also has. What about Jobita and Jasleen?
Yes, ma'am.
Jasleen also. Jobita also has. If vacations are going on, then at least we can have an extra class tomorrow only. I just want this chapter to finish at least.
Ma'am, tomorrow chemistry extra class is there.
Tomorrow already? Is there any extra class?
Yes, ma'am.
Monday, on
Morning.
Monday can we have? Monday morning?
No, ma'am.
Anytime you people suggest, any time in which you are comfortable. Tomorrow you have chemistry extra class. Yes, that Jobita has told me. Monday? Tomorrow I can. Tomorrow is Sunday, no? कल Sunday है ना?
Yes, ma'am.
हाँ, तो Monday को? Monday is fine. Monday morning is fine. Okay. Time, please suggest me the time. You all only suggest. I am available on Monday. Monday evening also I can. No, evening 10th की class होगी. Monday बताओ time. 11 KSA. Fine. Perfect. But I want a little longer class, not just 1.5 hour class, 2 hours class at least. So 12, 1. Yes, Jobita. Perfect. 11 to 1. So at least we'll be able to complete a portion. Fine. Before the next, again, we have to wait for Saturday, Sunday. And this week I want to take the extra classes. Okay, then 11 to 1, Monday. All right. Now see, third law of motion is basically all about the actions and reactions. To every action, there is equal and opposite reaction which occurs in the same body. There's a condition. Suppose this is a body A. This is body B. Now, body A is exerting force on body B. This is FAB. So this body B will exert an exact same force on body A, that is FBA. And both will be equal in magnitude but opposite in sign and direction. So FAB is equal to minus FBA. Now remember one thing, action and reaction occur on the same body. This means that if I have tapped on this, I won't get a reaction on the screen. If I have tapped on this tab, I'll get a reaction here only. So because it occurs in the same body, this will be cleared. See, a question comes, why don't they cancel each other? If action and reaction, they are acting, then why do not they cancel each other? So reason is that forces are same, but action and reaction act on two different bodies. That's why they do not cancel each other. It means, see what I was explaining you. Suppose this is my hand. I have, let's say I have dropped it, or let's say I have actually tapped on it. Let's forget dropping. Dropping mein to gravitational forces also come. This is, I have tapped. So this force from here will go into my hand. So force from pen to the hand, that is one force. So from the pen to the hand, from the pen to the hand. Now the reaction will be from the hand on the pen. Earlier, my hand was getting the force. Now the pen will get the force in reaction. That's why these act on two different bodies and they're instantaneous. It's not like I'll tap here and after 5 minutes it will also react back. Instantaneous process. Best example will be cleared through when a person walks on the ground. It's very, very easy and important for us. See, suppose this is ground. And let's say a person is standing on the ground, fine? Or walking, not standing, sorry, walking on the ground. Now, what all things will occur? Firstly, there is always a normal reaction which is added. What is this normal reaction? We'll talk about it. Normal reaction is actually a perpendicular force which comes into action whenever you have anything in contact. So a normal reaction will come and it is always perpendicular. This we'll talk when we will discuss fully in mass system. Or I'll tell you right now only, normal reaction is basically a force that comes whenever two objects are in contact, and always there's a force acting up in the direction away from the body at 90 degrees. We'll discuss this. That's I'm not telling you everything to write down. And another force which is acting is the gravitational force. They are balancing each other. Y-axis clear? Fine. Now, when the person has just put the heel, that is, strike the heel on the ground. So what happens? There's a force on the ground. When the person has strike the heel, there's a force on the ground. So there is a force on the ground. There's a force on the ground. Now, at the same moment, to balance us, if we just put and apply force on the ground itself, our bones, our body will not be able to bear it. So there, in order to balance this force, and we'll straight away fall down, because see, if a force is acting forward, we'll fall it. As soon as we'll put our heel off, we'll just fall. So in order to balance this, the ground also exerts a force exactly in the opposite direction with the same magnitude, which we call as the reaction force of ground. This balances the force that we strike. This is how we walk. And see, this is the reaction force. This has components. Properly, components are there. If this is R, so here this is making angle theta. Here we have R cos theta. Here we see this is R cos theta. This cos theta basically helps us to move. There's a force which is acting backwards. So then there's a reaction forward. So that helps in the forward propulsion when we are moving. So this helps to move. Why? Because if it is acting in backward direction, then there will be a reaction forward. So our body will be propelled to move forward. I'll explain this then again. And then here we have our sine theta. Our sine theta is basically there to balance the weight. Balance the weight. And what is this Fg? Fg is actually nothing but the gravitational force. Which always acts down. This is how we walk. So action and reaction are occurring. Yes, Zainab, see, when this normal reaction is occurring whenever we have two objects which are placed in contact and it occurs at 90 degree to each other, 90 degree to the surface. So when we heel strike, when our heel is striked on the ground, there's a reaction force exactly in the opposite direction. Now, how does this help is, if this force was not there, reaction wasn't there, then due to the forward force of the heel, we'll fall down, right? So there is a backward reaction force which balances it. And then this reaction force has two components, R cos theta, which is acting backwards behind us. So there is a reaction forward. Action, reaction. That's why our body tends to move forward. It helps in the forward propulsion. and r sine theta acts upwards, which helps in the balancing of the gravitational force along with normal reaction. Write it down. This comes, why have I explained this example in detail? Because this question often comes in the exam to explain the pattern of a person walking, explain the gait of a person walking, all right, or explain how the forces, how the Newton's third law is applied when a person walks. So that is important. Write it.
Ma'am, can you scroll?
Ma'am, can you scroll?